And you'll know it's on when.
Can you all hear me okay? Excellent. Thank you. Welcome, everybody. My name is Daniel Tal. We'll get started here. So I wear a lot of different hats. I currently work for Confluence out of Midwest. I'm their digital studio manager. So me and Jen Becker over there, raise your hand, Jen. I'm going to embarrass her anyway, even though she's not presenting. Work at Confluence running their digital studio. So we're responsible for 9 offices, training about 30 staff in visualization, drones, and AI. We'll talk about AI as well. And we do all their visualizations as part of what we do. We also have, this is more visualization, so a lot of fun with visualization. We also have a drone studio. I am no longer allowed to fly in the drone studio. I earned the nickname of Crash Daddy. If that says anything, not funny. I know you now. And I'm a fellow of the American Society of Landscape Architecture. In a previous incarnation, my primary job was urban design work in Denver, working on the Denver Justin Center. I've written several books on SketchUp and one on drone and technology with John Elchel, the fellow landscape architect. And we'll talk about drones and that technology. I have a website, www.danieltal.com, where you can find Placemaker, which we'll talk about, and Urban Paint, which we'll talk about. But I also have a lot of free YouTube videos for SketchUp, geomodeling, and also we're going to start adding AI videos. Who here is interested in AI? Yeah, great. It's all AI. So speaking of which, tomorrow we are giving at 3:45. We're giving me and Jen over there, who's my co-manager. This is version 8 of our presentation on AI tomorrow. We've been giving it around the country for the past year. It's a constant update. We've been researching AI for practice for 3 years. And it's, here, we'll start talking a little bit about that. So when ChatGPT 2.0 came out, it was called Playground. Anybody use it then? It was right before 3 came out. I've always been a science fiction fan. We're actually living in a science fiction novel as we speak. Honestly, it's no longer fiction. And we started researching AI, and our bosses came up to us and said, this is now part of your job. We're like, oh, cool. Raise? No raise. Anybody from Confluence here? Just making sure, other than you. They're all here, 17 of them. It's crazy. And so we've done a lot of research in terms of how that impacts that. One of the things that Jen does and responsible for is we do a bi-monthly newsletter. So our mornings are reading AI news. We both work remotely in Colorado, talking to each other over coffee about the current AI news and how fast it changes, but how little progress can sometimes be made. And this bi-monthly newsletter goes out to the firm. We also have ended up, since doing this, consulting with a lot of software companies. We're actively, monthly, weekly, talking to multiple companies about AI. Trying to make sure we have a voice at the table. And by the way, we'll talk about where we are in terms of all this. But this is a place that we go get our news, the Neuron, the Deep View. I have a feed. I have an AI feed that gives me information. But it's a rich source of information if you have to immerse yourself in the fact that we have to present on it pretty regularly, like we're presenting every other month. AI and employment. So I'm just going to start here. I'm like, you're all going to be out of a job. No. That's not the case. Regardless of what you think where this is all at, you are not going to be replaced. I could be very wrong, and there's aspects of it that can prove me wrong for sure. But right now what we've discovered, and we're doing a collaboration with UGA, it augments, in our particular profession, it can augment us in small ways. Not big ways yet, but small ways. And I mean, it really is, you're hearing it from all the top people. Now, I've also heard from behind closed doors, talking to people in the tech world, that they're being responsible about releasing this technology because they don't want to replace jobs. So there's an interesting there's a lot going on behind the scenes. And tomorrow we talk about AI and climate change and carbon footprint, and really how convoluted that conversation has very much become. Lots of propaganda. Um, there's a company that we subscribe to called Gartner. And really, if you talk about where AI is right now, this is called on this chart the trough of disillusionment, which is where we're all heading right now. Think about it similar to the AI, the dot-com bubble, if you remember that, and what ended up, Microsoft almost went away, too bad, after the dot-com bubble, but it recovered, unfortunately. But we're in that kind of phase again. We'll see how that works. And then we're not AI advocates. We're actually, we take weeks being skeptical about it, especially when you read stuff like this. This is not a human behavior when you have an AI in a test, because they're testing them behind closed doors in labs to keep them secure. And in this case, they were telling this AI bot it was going to be replaced. Your manager's having an affair. What are you going to do? And it decided at 80% of the time, it's like, I'm going to out that person. So we also have to deal with the bias. There's another one called the spirituality loop. This one's interesting. They test these AIs in back rooms to talk to each other. One, they want to prevent them from creating their own language to speak to each other, so they lock us out of the loop. Haha. And then the other one is they all end up meditating together. Yeah. It could be a ruse to be like, become in peace. But we talk about that. So this was the preview for tomorrow. We have 255 slides. It's pretty thorough. We talk fast. But let's talk about AI and remote sensing. And I'm going to give you a little bit of a history lesson here. If you have built castles in the air, your work not need be lost. There is where they should be. There is where they should be. Now put foundations under them. This was my first project, second year in school, Ranchway Feeds in Fort Collins, Colorado. I have no idea what we were doing. And one student brought up this idea, like, you have to start with the foundations of things. And our professor loved it. And we're like all confused, like, what does he mean? But it's become, for me, like the mantra of what I do. And again, coming back to AI, this isn't that long ago. This was 20th century drafting for, I thought that was me, right? And AutoCAD replaced it. Everybody knows that in this room, right? Because you're all doing AutoCAD. And that's the kind of way to think about all these technologies evolving in terms of what our profession does. And there's another aspect of this, like this is the source of base information that we have for creating foundations. Our foundations for all our projects are really based in hand drawing, going out doing a site visit. Next to our booth, there's a company, I think they're from New Zealand. They have a stick with a phone on it, and you can actually go out and walk around and measure the light, the landscape, and it uploads it. It's really cool. We're actually going to go check that out. But that kind of stuff is what we're talking about in terms of this revolution of where we are with information. So a little bit going down history lane. So in 1991, I took one of the last remote sensing classes at Colorado State University with the founder of Landsat, which really started out as a spy satellite in the Cold War, but was used to get really super high resolution imagery. And this was the beginning 53 years ago of where we are now in terms of what's accessible to us and what's impacted my practice. I love this class. I was taking a landscape architecture class. It was also when we had to take surveying classes, which I loved. And the aspect of it was learning, like we sat down with rulers and magnifying glasses and learned to identify objects on aerials. And he's like, this is how you find a tank. This is how you find artillery. I'm like, wow, I don't miss the Cold War. Maybe? I don't know. Anyway, but along the lines of, everything was analog. Everything about remote sensing was manual. And then at the same time, I end up working for a company. I end up working for CIRA while I'm at school, Cooperative Institute for Research in the Atmosphere. Just happened to get this job, and it's a collaborative with NCAR out of Boulder, NOAA, NASA, and the Department of Defense. We were just capturing weather satellite data. And I was sat down, and I was trained to interpret weather satellite data. I had to go look at the databases on these old magnetic tapes, and then disseminate them to scientists. And I don't know how I found, they also had a little remote control if you wanted to move the satellites, but I wasn't allowed to play with that, or at least not openly. But this has now become like, this is where you get your satellite data. And as I was researching to do this presentation, I came across their site and being like, I was using this kind of technology in an IT room 30 years ago, 20 years ago, 25 years, 30 years ago. And now it's like available on the internet as a browser. I'm like, this is the kind of stuff that you can go through and start. So this was part of my passion. Like, I love doing this kind of stuff. Then in 1999 to 2008, you had the change in modeling. So 1999, Revit came out, Rhino came out, SketchUp came out, almost all of them at the same time. They democratized modeling for everybody. This was me in 2005 using SketchUp to build cities, which is what I am still doing now. And on the left-hand side is really, that's when point clouds and LiDAR started to come online. You started to hear like, oh, you can get a point cloud for this. Well, what is that? And nobody really knew, and, you know, so here's the next evolution. And this is all exponential. Like, up until this point, humanity has been pretty much doing manual base maps for as long as written history has been recorded. And now we're at a stage where, you know, we're capturing high resolution data where you can see like the carves of a landslide and how that impacts how you study the land and how you can go about creating watersheds, making changes for whatever you need for safety, for power lines. Then fast forward to 2013, 2016, I ended up doing a stint working for a civil engineering company called Stanley Engineering. And all I did for 3 years was model infrastructure. I always wanted to do it. I loved it. Divergent diamonds, buildings. The best was where I thought working with designers, like landscape architects, are precise. And I thought the civils would be like so on it. No, they would give you a napkin sketch with a line, tell you that's a bridge, show you the abutments, and then tell you to design it. And I was like, oh, I don't think you want me to do that. I'm just right-brained. But it ends up like, it was a very enjoyable kind of job to do. But part of it was I had to build these models in a week. I had to build context models in a week. So I developed a system for myself modeling to kind of piece together base mapping information, aerials from Google Earth, or finding a terrain, or trying to figure out how to convert a DEM file in Bentley systems down to AutoCAD so you can import it into whatever program. And at the same time, the Phantom 3 drone came out. And I was doing seminars for Land Effects, and Jeremiah Trotter, who's going to the party tonight. And he's like, thank you for doing this work, because I did it pro bono. And he's like, I'm going to give you a drone. I was like, I don't want a drone. Gave me one anyway, and my friend John Altschuld, who wrote the drone book with me, we all started learning how to use drones in 2014 for the first time. I won't forget putting one up in the air. And again, like, this is still part of my career evolution into remote sensing and geomodeling. Ended up, you know, where we are right now. LiDAR is ubiquitous. That's a drone photo of one of our projects in Chicago. I wrote a book on drones, and I started refining how I started doing geomodeling for my own 3D modeling practice. I have a lot of hobbies. One of them is also, I'm a citizen scientist. I haven't done it in a while. Using your computer as a way to data process all the thousands of images that come from something like the James Webb. I had the James Webb unfolding in space live on my computer for 2 straight weeks, just absolutely stressed out. I love astronomy, just like it's the reverse of remote sensing. Instead of looking down, you're looking in. With that said, something people don't know, there were 3 Hubble telescopes built. Anybody who knows this? Anybody? What do you think the other 2 were used for? They pointed it at us. They're all for surveillance. They gave them in 2014. Those are high-powered live feeds. Just so you know where this all goes. You know, unfortunately, military stuff funds a lot of stuff for us. But yes, there's 2 Hubbles up there pointing at the Earth. So it just shows like how powerful the technology is. Then, unfortunately, September 11th happened, and everything changed, and people were like, okay, we're going to use facial recognition technology. So this is the first AI. Like, you can debate whether these algorithms are AI. They're smart. You can even debate whether the AI we're using now is AI. You really wanted to get into it. but the facial recognition work changed where remote sensing works. So full disclosure, I'm going to show you the stuff that I do that I have relationships with. But one company, so how does facial recognition work? So, right, it went from being able to identify a person's facial features, and then the driverless car industry got into it and said, okay, we can use these on cameras in our car, which is, I think, primarily the way Tesla does it, to identify features and objects. And the limitation they've run into with driverless cars, among other things, is they can't do parking garages, parkings, and construction, which for our country is kind of detrimental. But that technology in 2012, a company called Ecopia Tech out of Canada started applying their algorithms to high-resolution aerials by a company out of called Nearmap. Nearmap produces super high-resolution aerials. I use them regularly. We'll talk about this in this presentation. And what they were able to do is to digitize the aerials. So now you just are taking the manual remote sensing operations that I did, and now you have a computer doing it for you and building base files for you. How does that work? So I'll give you a quick example. So this is Meta's segmentation AI. They have a lot of stuff online for free, but what it does is, and this is remarkably difficult for a computer to do, it's called identification, classification, and segmentation in the machine learning world. I know this because my business partner for Placemaker, I kept telling him, well, let's just use Vision AI. We can build models. He's like, can you stop asking me that and go take a class on remote sensing and modeling on computer vision? I was like, sure. And I did. This was 7 years ago, and I understood then like how much data is required. So this is actually something that's very hard for computer systems to do accurately. So what we did, we took a drone aerial. This is when I was at DHM Design in Denver. And we had a high-resolution aerial that we did for a drone scan for Hudson Gardens. We sent it to Ecopia. I'm like, okay, show me. This was back in 2017. Show me what this technology does. How does it work? And it was remarkable because you could see the overlay. It produced one of the cleanest CAD drawings ever I've seen from that aerial, layered. All the information is orthogonal. I asked them if you can actually get this stamped and signed as a survey. I mean, this has been an ongoing conversation. They're hesitant to do that, but the data sets that they're able to produce are down to 9 centimeters. And that's remarkable in terms of what it can produce. So Ecopia is in the process of releasing this data set, and we'll talk about it in a second, but you can see here what's there. Like I have more examples of what their data set is, but like accurate, I'll just show you. So this is Denver, and this is showing all the different top-level layers of what's in Denver in terms of information, but it has driveways, it has sidewalks. They are even going to, they even have 3D models. These are accurate footprints of 3D building models. These are coming online now. This is the data that I want. I mean, so for Placemaker, which I'll show you, I'm its heaviest user by 20 times. And the other thing is it also is going to produce road striping. So what is this? This is the entire existing condition set that you have for your site locations, all the way down to the bollards, all the way down to the pedestrian lights, that you could start producing 3D models from that. So what we do was we took that data and then converted it to 3D geometry. So we can actually, and this is incomplete because it's not showing the bridges. They also have bridges, they have terrain. And that's the data, that's the next step of what's coming. I've been trying to talk about Ecopia Tech for years. Part of it is they've been slow to release their data. They're doing work internationally. They're doing work with lots of municipalities. They're doing work with the federal government. They're only now looking at the more commercial sector, like what we do for a living. But this is the stuff that I've personally been very excited about, as a geek in terms of building context models, because that's all I really do. And especially because, you can get all this mesh, all this Google Earth mesh data, which we'll talk about. But this is the kind of data you can manipulate, you can measure, you can put your models in, and combine it with the high resolution aerials. So it doesn't stop with Ecopia. There's lots of data. So the idea of Placemaker was born from me driving to work one day, looking at my phone and seeing Apple Maps and seeing 3D buildings and roads. I'm like, oh my God, this data is out there. How do you access it? Started researching it, turns out the 3D modeling program Blender already had this kind of app. What was it? City, might have been Cinematic 3D or 4D, where you can import some of this data, OpenStreetMap data. OpenStreetMap is a data set that's been around since 1982 that people fed in. It's a free user base where they add in their own information. So now you have Hexagon, which does rural areas, among other things, Nearmap, Mapbox, you have Google Earth data, you have OpenStreetMap data. All our projects start with Placemaker. Everything I do in my office is with Placemaker. I developed it for myself. It's been out for years. I went to an ASLA conference. I asked anybody if they've heard of Placemaker. Nobody had. I was like, maybe I need to kind of release it to the profession because it really is the way that we do all our work. This is a quick demo of what it does. I have a 10-minute demo as well, but I also want to talk about other aspects of this before we go into that. But this is Placemaker in SketchUp. It works in Revit. We have a cloud version coming, so it'll be universal for whatever program you're using, probably by the end of the year. In this case, it's importing in a high-resolution aerial. This was a presentation we did in Las Vegas last year, so this is the Venetian. But the high-resolution aerials themselves have become great because you can place them on terrain. And we're building so many context models. And it's not just that. The demands in terms of how fast we have to be to build these models has increased. So we can literally build, I'll show you an example of a whole city that we built in 1 week. And the fact that, unfortunately, they know how fast we are now at the office, so it's become kind of part of our every week. I blame Jen, but then again, you have to share the responsibility in terms of when you're working together. And I guess I should be talking about this video. So Placemaker's bringing in OpenStreetMap data. That's roads, that's building massings, that's the aerial, that's water bodies. It'll do subway systems, railroads. And then you can, as of last year, we went out and figured out how to bring in the Google Earth data too. And the Google Earth data has become wonderful because obviously for context, it kills it. We've also learned that Google has lots and lots of data. So you can import in 3 levels of data here. There's actually 4. You have low, medium, high, and max. I don't use low. Medium is for big context, and I'll give you examples of all this. And they have another layer that's hidden from the rest of us that's called max, like maximum, which is down to 6 centimeters, which they're not allowed to release because the federal government doesn't want them to do that. And just so you know, Google Earth started out as a CIA program. Does anybody know that? So Google Earth started out as a CIA program in 1985 called Keyhole. It was billions of dollars, bless you. And it got eventually purchased by Google, and they still continue to do it. They've gotten caught with tons of violations in terms of privacy. Again, like I'm not an advocate for big tech. Like I really like my privacy. But at the same time, it's remarkable data. So use it for what it is. And you can edit this data. So this is the Google Earth data. I go in here. You can see the mesh model in SketchUp. SketchUp has become pretty powerful in terms of being able to process lots and lots of geometry, like all the other big modeling programs now. It's actually the rendering programs that run into deficiencies in terms of processing geometry. But here I'm going to take out all the trees, and then I can replace them with my own digital trees later on. So again, like all our projects start this way. And we do all the major projects in our office, like from marinas to parks to riparian areas to you name it. Like we're across the board. And you can also take this data and convert it into AutoCAD, which I'll show all that as well, I hope. So this is an example. We worked in Kansas City. We were doing a study on Country Club Plaza. This is Google Earth terrain with using another tool called Landscape to drape the roadwork on the terrain. Then it's combined with the Google Earth data for context on the terrain. And then you have the building models and then the garnish. Sorry, not garnish. I know, we don't do garnish. Is that bad? Not a lot of laughs, I'm sorry. What? Broccoli? It's bad too. And it doesn't stop there. I'm a software developer as well. Like that's the other hobby. And this is where the AI stuff comes in. Like we developed Placemaker because of the fact that we knew there's an AI revolution going on in remote sensing, and we want to capture all that data. We were waiting for this particular moment in time, actually, which is why we're here, because it's finally here. I use Perplexity. Anybody use Perplexity? Ah, you like it. Yeah, it steals all your data too. And I'm able to use deep searches. Anybody? Crazy. You all need to come to the presentation tomorrow too. Trust me. I'm able to use these AI tools to further research all these data sets that are available, and did it this year and were shocked at what kind of data is actually out there. So for one, we found out that Google Earth terrain data is available, which is great because in some places they have it up to 2 inches, which is ridiculous, or up to 30 feet, or whatever it might be. But we've incorporated that into Placemaker, and now I can bring in some. We have a different terrain system, but this is far more accurate. I mean, it's really good, and we can create the terrain data out of it. But what we also discovered is that the USDA has gone out and has a LiDAR map for the entire United States. This is something that's ubiquitous in Europe. Europe has these data sets that we're showing you for their countries available for free, wholesale, and they want everybody to have it. We're a far larger country. Everything's done on a municipal level. It's a little bit harder to actually bring all this data together, but they do have it. And we're figuring out ways that we can start using Placemaker to bring in this LiDAR data into different programs. So all these different programs, SketchUp, Revit, Rhino, whatever, they can start producing models. So in this case, I'm using a tool in SketchUp called Scan Essentials, which will import in the point cloud and then allows me to create a terrain model out of it. Which you can see here, and it cleans it up. It's actually phenomenal. We use it for our drone data as well, and really gives you a very clean mesh to work with. You can adjust the parameters in terms of how tight it is, and that's not Placemaker. That's Scan Essentials. And then I'm moving a little bit quickly here because there's always more. I always run out of time. But then there's the ability to go from, we bring in all this Placemaker data into SketchUp, and then we can convert it out as a DWG. So it brings, because Placemaker will bring in road center lines, anything you really want. It's not survey ready or accurate, but you can recreate the contours as well. And this becomes our base mapping for our projects. I won't lie, we've actually won projects by showing up to the table, by having this data and being like, we're ready to start. We're not waiting 3 months for a survey, and then we add the survey later. And this has become part of my digital studio responsibilities weekly, is acquiring and disseminating this data to everybody. And then on top of it, I'm very right-brained. I can't code. My business partner said, like, you'd be dangerous if you could. And I figured out how to code to create, so this CAD process, which I had to do manually, I actually figured out how to do it in a one-button process. We're going to integrate it into the tool. So you bring in all your data, press one button, and it brings you a CAD file. And the CAD files are remarkable in terms of where you start with that kind of work. There's another tool that I use. This one's also, I didn't bring any leaflets for that one. It's called Urban Paint, sketchurbanpaint.com. I have a booth, 1715. I've never released this one either. Again, I create these tools for myself because I just want to make my life easier and not work 70 hours a week, which I'm doing now anyway. But at the same time, like, so what Urban Paint does is you draw a line and it lets you build an extremely detailed streetscape. So you can put in curbs, you can put in bike lanes, you can put in parking configurations, you can put in a median, you can put in big massing models, you can put trees in, you can put pedestrian lights in, you can put basically everything that I don't want to model. Which is pretty much, I hate modeling streetscapes. It's the same thing. It's really detailed, takes a lot of time. And we use this actively now for our projects more and more. We didn't think we would. You can see it's going through the process here. It's just all parametric. It's like you literally draw a line, select it, go through each one of those things individually, and then it will go ahead and you could save the profiles because you don't want to do it again, and it will build that profile automatically. And it's pretty detailed. Normally for somebody that's relatively new to SketchUp, like that could take probably, half a day, if not longer. And then I could do the same thing here, which takes even longer to do, is I can put in an intersection. And again, all these tools are born out of desperation and the fact that I just need to find streamlined ways to work in a process. And in this particular case, having the ability to create these kind of intersections and large networks of roads and systems is pretty useful. The other tool, and again, because people say SketchUp's not parametric, it actually over the years has become very parametric. This is not one of my tools. I helped consult on this tool. It's called Landscape. It's by two gentlemen out of Sweden. And this one's amazing. It's a very powerful terrain modeling tool. You just saw it create the terrain, and now it's just going to plop the site plan right out there. If I had more time, I'd actually do demos on this. I use this all the time. They're plopped in the aerial, and now it's just going to one plop. It'll do the entire site plan. This process used to be extraordinarily painful, take all day, because SketchUp doesn't have native terrain modeling tools that are really worth it. And this is, again, I'm working with all this different data. Here's another tool that helps with that kind of process. You see there it is, plopped right on the terrain. So just some examples of projects that we've done with this. And honestly, we can throw all of them in here. So this is Sioux Falls. And this is a combination of Google Earth terrain, a high-resolution aerial, drone data, and a high-resolution, and another set of high-resolution aerials. So we approach it from the perspective of piling on all this information, using it for building height studies, for section studies, but really trying to convey as much accuracy and context as possible within. And actually, I'm talking about that gentleman who just walked in the doors project right now. Hi, John. And again, like this is Austin. We're doing a project in Austin again, pulling in all that Google Earth data and how refined it is. Just showing you a near map aerial of Australia. This is the Flatirons in Boulder, Seattle, New York City, where I'm from, and Calatrava's Bridge on the top. This is Moab, Utah. And again, this is all Google Earth data in SketchUp. Stadium in Pittsburgh. We've never had access to this kind of data as a profession. And unfortunately, we don't have a lot of vendors that are going to give us access to this. We're kind of hidden, right? It really is up to us in terms of producing the tools we need to create this information we want. Part of the presentation tomorrow in AI is we're talking about AI really being the great customization. The ability for everybody in this room or in a firm to actually create the tools that they want when they need it. And that's actually what's really going to happen. That's at the foundation of all of it. Not that you can redo what Placemaker does. There's Devil's Tower. I think that's Wyoming. Hoover Dam. I mean, I downloaded about 80 gigabytes of data or about 500 models. It's just a little obsessive. I love this stuff. Like, it's just, I'm like, oh my God. And then, of course, it builds in all these massing models. This is Vancouver with roads and networks and stuff like that. So I'm going to do, and again, there's a cloud version coming, but this is, I'm going to talk through this longer version of how I use Placemaker because this is actually very specific to what we do on any given time. So here I'll open up Placemaker, and one of the things that you can do is there's a large area import on the right side. So this is in large area import. You can import in up to 10 square kilometers, which is the limit. You can't do that with a lot of programs. It's great for what I do because nobody wants small areas. Everybody wants very large areas. And this is the Tri-River area in Pittsburgh. Oh, that's New Orleans. Hold on. It's doing New Orleans first, then we'll switch over to Pittsburgh. But here it's the French Quarter. Thank you. And it's going to bring in this super high resolution aerial with Nearmap. And Nearmap's an interesting company. They're out of Utah. They were purchased by an Australian company who actually they purchased first somehow. So the coverage for Nearmap is interesting. It's for all the populated centers, 80% coverage of the US, Canada, New Zealand, and Australia. So for all you Australian LAs, you've got high resolution areas if you're working there. But in terms of what we do for our daily projects with Confluence, I mean, my requests are, most of my bosses, I have pending requests because I've been ignoring them for the past 2 weeks on bringing in some of this data for them. And you could see like it lets you bring in a sample to see what kind of area it is. So you could see the first aerial was the basic import. Placemaker, like a lot of things, is a credit system. There's a free version of Placemaker, and there's a subscription version. The subscription version, you have free access to all the Google Earth data. There's no credits. You have free access to all the OpenStreetMap data. You only have to pay for the stuff that we have to pay for the data. So then I'll go in and I'm going to say import this whole area in as a max area. That was too many credits for me to use. It was like 2,400 credits. I get in trouble with my business partner because I used too many credits. I think I went through 200,000 credits one year. You know, the average user goes through 5,000. He wasn't very happy with me. He cut me off for a couple of years. I'm finally in good graces again. But it's going to bring in, and I'm speeding up the video here, but it's going to bring in the high resolution aerial really quickly. And bear with me, I'm going to go through, I've never done this before, going through all the data sets for Placemaker. Usually I'm like, just go use it. But in this case, I've never actually presented any of this. So this is kind of exciting for me, especially if you see the history of how I got here and the fact that I could do remote sensing full time and I would love it. Not flying a drone. I'm not allowed to fly a drone. He's shaking his head, yes, and you're laughing. I might have crashed a drone in Chicago and in Colorado. Yeah, thanks. I had to make sure the propeller flew off. It happens. So you can see that's a high resolution aerial. What we do with these, and I have workflow videos for them, is we then export them out of SketchUp. I then use an AI tool called Tobas. Anybody heard of Gigapixel? We're going to have fun tomorrow. They're not newbies. It lets you take low resolution images with a high, and then you can make it up to 4K using AI, which is also part of our daily process. So we actually take some of these aerials and reprocess them to get it even to a higher resolution aerial using AI. So AI has seeped into our workflow for all the projects that we're doing at the office. And most people aren't aware of it. Like the project managers don't know. I'm like, here's this data. So it's just magic. But like in this case, it becomes fairly important to be able to convey that information. So going to the next part. This is a bit longer. So now we're going to do probably one of my favorite areas. And this is using a large area export. At the top right, you could see it. That's probably about 1 kilometer. And the thing is, with all this kind of data, you're accessing the cloud. So we're accessing whatever service this is coming from, Cesium, Google, Nearmap, whatever. And so you have to break up the aerial to actually do this into a way that makes it manageable. In this case, I'm bringing in the high resolution aerial. I sped this up. This process can take about 5 minutes, especially because it's bringing in all these tiles. These tiles are the aerials you see in the world, and they're each very high resolution. The smaller the tile, the higher the resolution. So again, you'll see, I'll zoom in here, and you can see it's a super high resolution aerial. Our world is pretty much very digitized at this point, especially because of driverless cars. They need that information to get them to drive, and for surveillance and for whatever else. And then what I'm going to do is I'm going to unlock this aerial. I'm going to explode it. And then what I'm going to do is I'm going to partition it into 9 different parts. And this is, again, workflow process, because if I try to do this all wholesale, the data requests to the cloud to pull the data would time out. That's too much data. That's too big of an area, especially Google. Google guards their data like you wouldn't believe, which makes sense. This stuff is valuable. It's really information on the earth, especially like if you look at all the conflicts in the world, they've tied down the data from those locations so people can't use them for military uses except whoever's allowed to. Okay, but more to this, what I'm doing is I'm partitioning this into 9 different, again, just because it's a bigger area. Most of my projects, I don't have to do this. But again, I've never had the opportunity to show this process. I'm going to turn I exploded it, so again, and then we're going to start bringing in, the first thing I think I'm going to start bringing in is terrain. And I'll start bringing in the Google Earth terrain. And I chose this location because it has a lot of terrain. And I actually know for Google, they actually have it down to 1 meter resolution for this location. 1 meter resolution on demand is amazing for what we do. And you can see it right there. How subtle that data is and how hard that is to get. For me, it's always been mind-boggling to work on a project and somebody sends me a survey. I'm like, this is the survey you have for this? I'm like, this is terrible. lines don't meet, missing information, where the building footprints are, there's no grade, or whatever it might be. So it's like really giving us access to this kind of information is probably the most important part. It's going to speed through the process now of doing all the different segments at the same time. Is this interesting? There's cards for Placemaker down here. Highly encourage you to use it. It's not the only tool. Like there's more tools. Like these tools, you're going to start seeing more and more of these AI generated data. Part of it, what we're trying to do working with these vendors is to bridge the gap for us. To be like, oh, because they don't know how to deliver the data, any of us. They don't know how to reach even architects. So here you have it. There's the terrain model for this location. And usually for most of my projects, I stop here. I usually just give them the high resolution aerial. I'll export the aerials out of SketchUp. I'll then manually import them into CAD and scale them into CAD for that. What I've also learned is that once you bring these, if you import this into rendering programs like Lumion, Enscape, Twinmotion, or D5, whatever one you're using, the resolution is actually better in the rendering program. SketchUp actually dumbs it down a little bit for processing speed. You can see right here, I added the contours. I used an extension. I can export those contours out to CAD, and boom, you have your base files. And we've been doing this now like this for about 8 years. And this has become our standard practice. So the next part of what we're going to do, I think I do the Google Earth 3D. So it's going to do one of them. Now, the way that you do the Google Earth 3D is you have 4 different levels of detail. I'm starting with medium because it takes time. Like the more refined the detail, like the medium detail right here, you're seeing it, it's in real time. I didn't speed it up. So it's building in that detail in real time. And it's really beautiful for Pittsburgh. The next detail up is the high detail. And this actually took 5 minutes to do. And then the next one is the max detail, and that took 10 minutes to do. And this was actually cool to watch this. I had to watch this in real time. I'm actually deselecting the water because I don't want that to be high resolution because I don't need to actually further burden it to keep going with this data. So then I'll hit it, and it's kind of cool to watch how this data is built and how they actually, from my perspective, how they scanned it, how they built it, how they put it together. Like all these little pieces together. It's just cool. Looks like they're building the Matrix. Not bad. When we first released Placemaker in 2017 and we did a survey, we asked what people wanted. They all said the Google Earth data. So we waited and they finally released it. Now, not all places look this refined, depending on where you are. But this is global. Like I'm pulling the Eiffel Tower, I'm the Ferris wheel in London. Like I'm having fun with this. Dubai, I'm like, oh look, the Burj Dubai, because I worked on that project at some point. The Brooklyn Bridge was really cool, and some areas have really, really high resolution data. And we've noticed that Google doesn't announce when they release the updated data, but they do. And at some point, the max data, their really high level of data will be really released. So there I brought in everything else. I spared you the problem. This took about 30 minutes to build. So there is a process. This does take a couple of hours to build it, but it's not bad. And there you can see there's the complete data set. The bridges are in there. Feel free to plop your project in there. And what we do is the data is manipulable. So we delete stuff out. We combine the data sets into each other. And in this case, I'll just show you the stadium. You can further refine the data. So like what I do is just select it. You bring in the data and selectively increase it depending on what you want. I like the stadiums. You can see the high resolution aerial underneath it. And it'll bring that in. I sped up this process again. Almost done. I'm going to fast forward a little just because we're running out of time. So, okay, so here you have all three. You have the Google Earth data, you have a terrain model. Everything's layered, so everything's kept organized. Everything's kept organized on layers, tags. It's an issue. And what I'm going to do now, same thing. I partition this. I'm now going to bring in the OpenStreetMap data. Roads, water, paths, rails, buildings, whatever else. And this data is great because it's really the biggest basis, especially because you can export this right back out to a CAD file. So you have the building massings as CAD bases. You have everything. You have the whole road network. But you can see I'm doing this in real time. I'm just clicking on it, hit import, and we have access to 225 million buildings for the US alone through the Microsoft, because Microsoft is also releasing their data. There's competition between Google and Bing, and Bing data is phenomenal data. And also, like, because they have hidden oblique data, like they have bird's eye data that they don't show you anymore, but we're trying to get access to that. But in this case, what you're seeing is I'm bringing in the open, and you can also drape all this on terrain. This works on terrain as well. There's a button that says merge with terrain. It'll put everything on there. And again, all this gets exported back out into CAD or whatever it is. It's used in our renderings. But again, like it's the rare project that doesn't get this treatment for what we do. And it actually saves us. People think we're miracle workers because like, how did you do this context? I'm like, let me tell you. And it's easier than flying a drone to obtain this data. We do both. I don't, but other people in my firm do. So the next thing it's going to start bringing in is, I think I'm doing roads. And again, for the roads, I'm just going to, oh, there's the water, which is great for rendering. Don't have to do that. Then it's doing the roads right there. I probably dropped way too ahead here. Those are paths, sorry. So that's the path network for there. So roads, paths, water, buildings, and the aerial. It's interesting to know and find out how much data is actually out there that's been digitized, that's been made available. And unfortunately, and it's not a bad thing, Esri's been the gatekeeper for all this, and they haven't been particularly good at disseminating it. That's why we're producing a cloud version of this, so you can actually also import this into GIS. And part of our presentation tomorrow, we're talking about another company called Felt, F-E-L-T, terrible name. But they're an online map GIS platform that's very easy to use. So you can see right there, I have all three levels of data in there, all in one model. The Google Earth imports make for very large models, I'm not gonna lie. So do the aerials, like 200,000, 200 megabytes, 500 megabytes. Yeah, just so you know. We're running out of room on our server. Hint, John. I might be looking for a new job later. So there's more. I'm almost done. So examples of how we use this. I just have one. The other one I forgot to load, so I apologize. I was told this is Gretna, Nebraska. I pulled in the Google Earth aerial for about, I don't know, the whole area, and then brought in the building massings. I was then told that I had 1 week to model this master plan. I was like, that's not a master plan, it's a diagram. They're like, yes, but we know, again, they know how fast you are at some point, so, it becomes problematic. So what I started with is I drafted road center lines. Just did this in SketchUp. I have a CAD background, did 10 years of CAD. I'm actually faster at drafting at SketchUp at this point because I live in SketchUp. And then was able to reproduce the master plan pretty accurately in SketchUp. You can actually use the colors. I took the colors and created it. And then we started adding building models. And really the analogy to what we do is we're the guys, the people in the basement that are manually building your models. We just now do it digitally. But honestly, it's the same process and the same timeline. And we have all these buildings, so we start manually rotating, placing, scaling buildings for the entire concept. This is day 2. We do have and we do collect, and part of Placemaker is you can download some of these building models. So if you get Placemaker, there's also a bundle that comes with buildings. So we have to update. But we keep a whole building bundle. I have gigabytes of buildings for all our projects. We're actually having people in our office model more. Then I use Urban Paint, the streetscaping model tool, to create all the streetscapes and intersections. You can see that here. This is actually a quick video. Like I create the profiles. It takes about 20 minutes to create and save the profiles. Then I'll go in there. And again, everything you're seeing, you either can't model or we're taking weeks. We're doing them in half a day. Detrimental to my workload, but at the same time, we can function at high levels and produce a lot of work and go through a lot. It's fun to do all these models. Like we can do a lot of modeling for our firm using these tools. Here I'm picking the street lights. I guess we're getting another demo of Urban Paint again, which I have no information on where you can get that, sorry, but look up SketchUp Urban Paint, hopefully it comes up. I'm terrible at marketing, I apologize. It'll do the intersection. Which is just fabulous to be able to do this. And then that's how we did. Everything goes into Lumion. Everything is layered. And it's produced on terrain as well. So 1 week, that's our process. And every time we do one of these projects, it's finding a way to get faster. We did another project like that, but I'm going to skip that for now. I'm going to quickly end with drones, because drones is part of our workflow in our life. Again, this is Fall Park. This was a beautiful place to fly the drone and get data for it. We use AI to manage the drone studio. So we have about 12 pilots. Someone crashes the drone. They don't want to tell us why. We already know. You can track all the information. This is air data. It's been set up so it tracks your batteries, it tracks your drones, it tracks your pilots, it tracks your flight. Who's flying drones? Anybody? Cool. And the different uses we have it for. So that's a photo merge on the left with the drone footage. On the middle is drone-derived terrain data. So you can create the photogrammetry and then the aerials themselves. I think the picture on the left is interesting to me because we're going to show you tomorrow all these generative AI images. And that looks like a generated AI image, but it's actually a drone shot for a Chicago project. And just using these for photo merges. So it's really enabling us with all this technology. There's Falls Park again to do it. This was one project where we flew it in Centennial, Colorado. We flew the drone. That's a photogrammatic data set from Pix4D. Got the high resolution aerial out of it. You can produce contours from the drone data. And then the specific part of this is we had to do very specific view shed studies because the neighborhood did not want this development. And so that's what we did. And these were accurate. Like we had actual heights and charts to show that this was fully accurate. And again, we built out the entire corridor and area in Placemaker. So all these proposed and existing buildings that came in, we used the Google Earth data as well.